child goes down a slide in a playground. So the situation is we've got some kind of angled ramp that a child is going down. And there's no friction between the surface of the slide and the clothing. Which of the statements are true? Does the child move down the slide with increasing speed or constant speed? Because of gravity, the child's going to be pulled down and accelerated. Now, the free body diagram for this child, though, is this. There will be a weight, Fg, and there will be a normal force, but because it's at an angle, normal means perpendicular to the surface. And so since this is the surface, we want to go perpendicular to that with our normal force. So we would see something like this be in the force diagram. And those are the only two forces that are relevant. However, what we can do is we can break up Fg into its components. But what we like to do, though, is align it so that this is the positive x direction. Like you want your axis to be aligned with the ramp surface in these types of problems. Yeah, so that when you break down your components, you create an x component called Fgx, and then you create a y component called Fgy. And this is all part of analyzing an object on a ramp. And it's supposed to be that it makes a rectangle here with the original weight vector. So this is the original weight vector. And now we can see what kind of forces we have and what kind of balance we have. So what we end up with is we've still got that normal force, but now we replace the Fg with Fgy and Fgx. This shows that the forces are truly not balanced in this situation. Even though the forces like here are balanced, Fgx is not balanced with anything else, which means the child will accelerate down the ramp. She doesn't accelerate like into the ramp or fly off the ramp either, though, and the reason is because Fgy perfectly balances with Fn. So it is true she will go with increasing speed because of the unbalanced force. So this one would be false. Is the net force acting on the child zero or non-zero? There's an unbalanced force, so this one's true. This one is false. The acceleration of the child is constant in the direction down the ramp. It is true, yeah, that's kind of a tough one. But it's because Earth pulls the same on her no matter where she is. Like if she's at the top of the ramp or at the bottom of the ramp, Earth is going to pull with the same strength at both spots, so the acceleration does end up being constant, yes. Let's see. The child moves down the slide with decreasing speed. I mean, that could be true if there was friction, but that's false in this case. She's going to have increasing speed. We said that up here. The forces acting on the child are unbalanced. That is true. Forces acting on the child are balanced. No. And the child has a non-zero acceleration on the ramp. It's true. And the reason is it comes from Newton's second law would tell us F net equals ma. And so if you have a net force, which we do, Fgx is the net force, we'll also have an acceleration.